Okay, we're going to get started. Hi, everyone. Hello, everyone. Happy Monday for most of us. Today is March 14th, 2022, and you're here to attend the professional learning series for our spring, for our winter. We're at the end of our winter season. Today's focus is on equitable CS assessment practices. We're so glad you could be here today. So in the chat, we'd love for you to introduce yourself, your location, and what's an assessment or strategy that works for you as a learner. So think about when you're on the learning side, what works for you? For example, when I was a student, an effective strategy that an instructor would use for me is when they would ask me to write my own test questions, and they would always feel good whenever I saw a question that looked similar to mine on the test. So we'd love to learn about what's working for you all. So in the chat, your name, your location, and something that's working for you as an assessment strategy as a learner. Okay, awesome. Thank you all. Rubrics are cool. So thanks. We'll just keep putting that in the chat. But I'd love for us to draw our attention to our guest presenter today. Actually, we had two people slated for today's webinar, but one of them could not make it today. But we have our rock star in the house. We have Ruth Farmery, who is currently a director of K-12 Computer Science at Prospect Hill Academy Charter School in Cambridge, Massachusetts. This workshop is being brought to you backed by popular demand. It had been presented in the past, but it garnered so much attention, and we definitely wanted to provide another opportunity for our members and our guests to learn more about some equitable CS assessment practices. So I'm going to stop my share and shoot it back to Ruth.
Hi, everybody. So we actually have Nearpod slides from when we gave this back last summer. So there is a link in the chat so you can follow along. All the links in the Nearpod are embedded, so you can open them up as we go through. And Jason's going to share the view of it. And yeah, I'm on my own today instead of with Ariana. So I get to say all the words instead of having a break at sometimes. So the objective of this is to think about reasons why traditional assessment methods, particularly those in AP, CSP, and CSA, might lead to inequities, and then to identify other more equitable assessment strategies to use with students. There will be a lot of examples from AP CSP and AP CSA, but it's not to say it doesn't apply K-12 and in other courses. But as we teach those classes, those were the examples that were kind of easier for us to include as well. So we're going to start with talking about the purpose of assessment. We're going to look at what are the problems with some of the more traditional assessment strategies. Then we're going to present some other ways that we use assessment in our class, and then we'll do some closing at the end. So there is a link at the moment, the one that says resources is a link to all the resources that are in this presentation and some other things. But I will also put that link in the chat. People wanting to explore things. So in starting to think about assessment, I'm going to start with some input from you all. So you should see, if you're in Nearpod, you should see the question on the screen, which is, what is the purpose of assessment, and what is formative and summative assessment? I'm going to put the link back to Nearpod chat. yeah, you can, it seems to be NewPod has added new things, so you can write comments to other people and you can still like things. It looks like we have a bunch of like agreement in checking for understanding, to have students show what they know, to give feedback both to students and to teachers. I like liking the comments with other people as well. I think I can do it as well. Oh, and we, there will be time for like questions at the end. But if people have questions, please interrupt me. I'm going to give people a chance to just finish what they're writing and then I'm going to move on. So it seems like we kind of have an agreement around this, but like assessment is the bridge between teaching and learning. Assessment is how we know what students know and don't know. However, while assessment is the bridge between teaching and learning, assessment and grading are different things. And when I'm not going to really get into grading that much, although this year the new thing for my school is that we have moved to fully standards-based grading for all subjects, for all students. And so I do like to talk about grading as well. And I'm happy to talk about it, but this is all going to be about assessment. So Dylan William is he's a British educational researcher, and he wrote the paper on assessment for learning, and which kind of introduces formative and summative assessment. And there is a link in the resources document to Dylan William giving this explanation of his analogy, but I do quite like it. His analogy is if we flew a plane like we approach teaching, then the pilot would close the doors, fly for 8 hours, land in the nearest airport and look where everybody has arrived. And then everybody gets off the plane wherever they've landed, whether or not it was where they intended to go to. And his analogy is that, if we approach assessment in only giving summative assessment, this is like just flying the plane and seeing where we arrive. Whereas pilots don't do that. They're constantly checking all their instruments and hopefully landing in the place that they intended. And formative assessment is the thing that gives feedback to teachers and to students about what students know and don't know, and where individual or whole groups of students need to improve and develop before you get to the summative assessment. So when we were when we were coming up with this, we defined what we think a good assessment strategy is. And the things that we came up with, that an assessment strategy assesses what the students know and don't know, but particularly it's assessing what students' computer science knowledge. It's not assessing the other things that they maybe do need to know, or things that we don't want to assess, like the quantity of work, for example. And that a good assessment strategy makes thinking visible, and so it gives us insight into students' thought processes, so we can really understand where they're coming from. That it supports students in understanding their errors, and that it prepares all students to succeed on summative assessments. So, what else is missing from our assessment strategy? What would you add to it? You can either add your thoughts in the chat or just unmute and comment. I'm not very good at reading the chat. yeah, I think having some element of self-reflection is really important. Having students understand where they are and students reflecting on whether that assessment method works for them or not. Yeah, self-checking. I think I've had this discussion every year in 15 years of teaching of like, what is a good way of assessing students that is not a burden on teachers? I still don't think I've come to a good answer. Yeah, do students know what they're doing? Yeah, self and peer evaluation are like things that really go with formative and summative assessment. They're not really things I'm going to talk about today, but they're definitely linked. Okay, so this was kind of, establishing what this is about, what's formative and summative assessments. So now I'm going to move on to like the kind of problems with some of the more traditional methods of assessment strategies. So this is a multiple choice question. It's pulled from the old APCSP specification, but it is kind of an example of some problems. So the kind of context for this, I had taught, we'd done like a week's worth of stuff. We'd taught them all kinds of things. We actually, we actually now teach our whole 10th grade APCSP, but it has always been a 10th grade class. So I gave this question to students and I really did expect them to be able to answer it. And of my two classes, my class in the morning, like hardly any student knew the answer. I was like, why do they not understand? And the reason they didn't understand was they didn't know what an underlying assumption was. So like, while you might look at this question and say, well, what is this question assessing? Well, in theory, it's assessing Moore's law. What this question was actually assessing was the English proficiency. And because they did not have the academic vocabulary to answer the question, they couldn't access the CS content in the question. When I asked my class in the afternoon and I defined for them or asked them if they needed me to define any of the terms in the question, we're all fine with answering it. Their CS knowledge was not an issue, but they're like the way the question was written for them was. So we have some more examples. So we have a lovely question here, a Java question. So there is, we also have like a Scratch example, if anybody wants a Scratch example. But my question is, what is this question, this quite long multiple choice question, what is this actually assessing of students? As a Scratch example, if you want to see a Scratch version. And I would invite you to comment in the chat, what are the things that this question is assessing? Yep, it's involving code tracing. You need some knowledge of Java methods and classes. I mean, this question also has in it, the code also has in it if statements, and it has a loop, and it has math.random. So there's an awful lot in this question. And if a student gets it right, well, then you might be able to say, okay, they understand all these things. They understand how classes are working. They understand how, you know, objects are created. They understand like loops, and they understand conditional statements, and they understand all these different things. But if they get it wrong, it's kind of hard to figure out why. It's not really clear like where their lack of understanding is. And for the student as well, they probably actually can't tell you why they got it wrong. And, you know, a few students will guess, and some will guess right and some will guess wrong. And that doesn't really tell you anything either. Yes, right. You might know that they guessed well. You do have students who are particularly good at guessing, but it's not really with the, you know, an assessment that gives you feedback on what you know and don't know. It's really hard to tell from a question that has so many skills built into it where areas of misconception are. There's also, like, you know, the AP exam has 40 questions in 90 minutes. So this is also expecting students to like read all this and process it in a really short period of time. So then we've got another example. This is also from Java, from one of the free response questions from AP Java. And so then my question for this is like, you know, why is this question like, you know, what is this question assessing, and what are the things that are actually not CS content knowledge? What are all the other things that this question is implicitly assessing? And if you don't teach AP CSA, this is one of 4 questions that you'd be expected to answer in 90 minutes. So as you look through this question, you know, why might this question be assessing things that are not CS content knowledge? Yeah, there is so much reading in this. And, you know, if you're a student who maybe like English is not your first language, or, you know, maybe just your reading proficiency isn't something that you are, like maybe you just read slow, to process this amount of text and write the code in 22 minutes is a lot to ask of somebody. I would also argue when it comes to this question that, you know, if we want students to be interested and engaged in computer science, that this question is like boring and applies to nobody. And probably when you know, once you've written the code that makes it work, you're probably not particularly that excited by it. And while there are some students who, you know, are interested in just writing code that solves a challenge, whatever that, you know, getting the right answer, this is not really opening up computer science to a more, you know, a wider range of students. And it is, I mean, now College Board have changed their way they structure free response questions. So they are now, specifying this question is asking about this specific thing. Like this question really is testing the reading comprehension more than anything else. So, we like, especially if you are an AP class teacher, but whatever class that you're teaching, we do want students to be able to show what they know and what they can do. So now I'm going to present some strategies that we do use when, not only to build student understanding for AP exams, but just, to assess students in general. So these strategies are Parsons problems, the frame model for code tracing, some code annotation and video response, and then we're going to get into kind of project-based assessment and rubrics, which is kind of more towards the grading bit. So if you're not familiar with Parsons problems are where you give students the code in blocks that is not in the right order, and then the task for the student is to put them into the right order to solve the problem. There is a link there for you to try it out yourself. You may need to be logged into, this comes from the CS Awesome curriculum, which uses this a lot. You might need to be logged into the CS Awesome website for the link to work, I'm not sure. But you can try it out yourself. But if we think about Parsons problems in general, like what is this assessing and how is this supporting students in in demonstrating their understanding? And other people can unmute, so it's not just me talking forever. Yeah, I like these too. And I think there's something nice about the physical one when you have it, when it's like on paper and in the classroom. Yeah, it removes the detail. The distractor blocks is a nice way of like extending them. Yeah, there is, I've seen a variation before where you just put them, like you put the blocks in every order possible and see what the different outcomes are and describe the outcomes. And yeah, it takes away, especially for Java, which is particularly strict in its syntax, it takes away that need to have all the syntax right. And you really can just test their understanding of do they know what the structure is? Do they know what order it's supposed to go in? So that's an example from the CS Awesome curriculum. We did, like, this is Ariana's example. Ariana did make her own. The adaptation she put in is she also added some fill in the blank sections as you go through these. I think you can, this should be allow you to take a copy of it. So then not only does it build in the kind of like Parsons problem element of of putting it in the correct order, but it starts to extend students into asking them to write parts of code, if not all the code. I don't know if interactive Parsons problems exist for Scratch or Snap, although Scratch kind of is its own Parsons problem because they're jigsaw blocks, and so like a started project would be. With all the blocks, maybe some of the extra ones would be. Yeah, make a project with all the code blocks in it and have students remix it, and it is essentially a Parsons problem. And if you're looking for the link to something, there's a document with all the links to everything that's in this presentation and a link to the presentation itself. So we use Parsons problems like in all of the, like in most of our classes, we really kind of like Parsons problems. They do allow, they remove that kind of element away from students in the syntax element and gets them really into the problem solving bit of it. So the next strategy that I have is kind of moving towards the multiple choice questions. So a Freya model, if you're familiar with a Freya model, I think they're from science and maybe math, and they're used for vocabulary. So you put the word in the middle, and then you have the definition and the characteristics and the examples and counterexamples. And so adapting that Freya model to then allow students to kind of make their thinking visible for multiple choice questions is to take the multiple choice question and put that in the middle, and then expand on the multiple choice question rather than just answer it, but to really break down what is that question actually asking of you, what knowledge and skills are required to answer that question, and what is the process for answering the question, what is the right answer and why is it right, and why are the other answers wrong. And so students, I will give them the multiple choice questions, and then they produce this kind of diagram. Some of them look like that, a lot of them don't actually look like that, but right there. So I have some examples of this that are completed by my students, so you have to kind of bear with their writing. So they've got the question, I think this is the code.org question, and then they have the sections of that Freya model. So there's the description of the content knowledge that they need, and then there's the what are the correct answers and what are the wrong answers. So by doing this, students are able to kind of give you and them more information of they can't really I mean, they can still guess, but they need to give a reason behind it. They also are they actually have to read the question, which is good for them. And then, it's helpful for you and them. When they don't know the answer to the question, it's a lot clearer, because then they're sat there going, I have no idea what to write in this. The other thing you can see, I think if you scroll down, there's some example of some other questions. There's a student who got the question right, but their reasoning is entirely wrong. It's some kind of accident. I think that one's, I think this is the last one. It's a student who answers the question right, but if you actually read what they've written, they really don't understand that the concept at all. They just accidentally write, and that would not come out in a multiple choice question. You just think they kind of know what they're talking about, but they actually don't. So, some ways in which we use this in the classroom, we might have all students doing a different question, and then they're going to share them between them. or we might have like, you know, a short set of questions that students are working together on them and then sharing their answers. And then this also helps with the understanding of the academic vocabulary and the way that the AP questions are phrased. And please feel free if you have questions to put them in the chat or unmute and ask. So in terms of our next strategies, one of the things that we generally like to ask students to do often is to describe like code and to kind of narrate themselves tracing code. And so we're just going to watch like a minute or so of a student doing that. I'm not sure where the sound is going to come from though. I think it might come, Jason, I think it's going to come from you. So I might have to mute and you unmute.
Which is equal to the string to Pica. In the first line, it.
Do you have to share the video? I can stop sharing and you can share, and then I can share.
I think I might have to share it. Sorry.
And then the int year, which is equal to 2016, and then the battery is equal to 100. Then in the next line, it's going to call the method play games, and in play games, it's going to make the battery equal to 25, meaning 5 times 15, which is 75, so 100 minus 75 is 25. Then the next line, it's going to, that same object is going to call charge Chromebook, and in charge Chromebook, it's going, and it's been for 5 minutes, so it's going to be 5 times 10, which is 50, and I'm going to add that to the battery, which is going to equal to 75. Next, we're going to change the battery in battery change. So it's 4 years old, meaning that 4 times 1 is 4, and then the battery minus 4 is equal to 70.
So that continues. I'm going to stop sharing, Jason, and then maybe you can share. So, that was Maya kind of explaining how she follows that code in Java. We gave them the templates and then we just asked them to use the screen recording software to record what they, how they traced the code and what the outcome was. The reason that we ask students to do this rather than just have them answer the multiple choice questions that are code tracing is it's really it's hard for students to kind of fake their understanding in a video. They just they'll get to a line and they'll be like, oh, I don't know what this line does, I'll just move on. And it gets them to an answer and it's helping them set up that structure for being able to answer those questions. those videos do take a long time to watch. They do take a long time to make, but they are in supporting students in developing those skills. The videos really help them kind of, understand that process. We have had like students just do it and like do it together. But then of course, like if you're not listening to the student at the time, you don't actually know what they've done. And so like we have them create the videos so that we know what they're doing, and then we can see where they're going wrong in that process. And I think that the template is linked in the resources document. So then the last thing that I kind of want to talk about is assessing proficiency with rubrics, and this gets more into the grading as well as formative and summative assessment. So like our school has moved to standards-based grading in its entirety, so we now don't deal with points at all. But so assessing students' coding proficiency or whatever it is on a scale using criteria, and giving students projects that allow for flexibility and creativity in responses from students rather than just one very prescribed project and and problem to answer, but it's still assessing the same standards. So there are a bunch of examples in this document that come from different places. We do ask students to write reports on occasion, as well as just write the code. And that is the example from, it's kind of the image lab from CSA, but it's a bit changed. And so, we have the code rubric that has some specifications of what they should have to do in it. We have the report rubric that gives them a fair amount of requirements. And then we have some other examples from APCSP, and then a general example of a code rubric from a programming class where it doesn't really specify what it's assessing. It could be used for any kind of code concepts. We would often fill that in to if it's assessing something specific, to say what it is assessing. And so we assess on an advanced, proficient, developing and beginning scale. Before we move to standards-based grading, we would have like allocated grades to these. And so we used to assess on the scale, beginning is 60, developing is 75, proficient is 85, and advanced is 100. We never give grades below a 50. We have now moved into standards-based grading, where we actually just report advanced, proficient, developing, beginning. So give people, and we use rubrics for everything that's formative or summative. So I kind of got to the end, maybe a bit of a short presentation, but time for questions. Yeah, we would use a similar rubric for students talking through code. I think there is a little bit of that on the end of it.
Ruth, can I ask a question about the standards-based assessment?
Yeah.
So my understanding is there's no longer a number attached. So how does that translate to like progress reports and report cards in general?
So it turns out like we went for a system where there is a number attached because we decided that we did need to be able to average things, and so you have to attach a number to it, but it's like the numbers are 4, 3, 2 and 1, but what we report is like proficiency on each of the standards, then with an overall average of the proficiency on each of the standards for the class.
Thank you. There's a question in the chat from Chris Stickney. Do you see that one? If you are standards-based, is each project summative teaching just one standard or more than one? In other words, do they get more than one score per summative? Are you using state standards or national?
So like the summative projects, it kind of depends on what class it is, but most units have 2 summative assessments in each unit. And like, because it is AP CS, like because I teach AP CSP, we actually pretty much for every unit have a project, and then we have a multiple choice test because they need to practice for the exam. And generally they are testing more than one standard. And then we are using a combination of state standards and national standards because we're using like the Massachusetts state standards and then some of the AP standards when they're AP classes. But we did write all our own standards, and I kind of based them on the CSTA standards, but took out the ones that we don't really address. So that's where they came from. If anybody wants the standards that I'm using, you can have them, but you might want to wait till, because now once we've gone through a year, we're going to revise all the standards based on how they work in practice. But I'm happy to share them with anybody who wants them. But they definitely need to revise them for next year. I realized I do have a last screen. I just have a, like, you know, what is your key takeaway? What are some questions? What are other things that people are doing that are not in our presentation?
Can I comment, Ruth, that the Freyer model, I think, is just a perfect way for when you're dealing with multiple choice questions for students to justify their selection, and then also being able to identify who's just guessing and who is just really good at guessing. I mean, you know, some people have a knack for that, but especially for those multiple choice questions where there's one more right answer than others, this enables students to be able to figure out why they chose the one that they did. So I really appreciate you calling out the Freyer model.
Yeah, so Angela, in terms of what makes these assessment more equitable than other types of assessment, that kind of goes back to the things that I said at the beginning that we identified as like our priorities for assessment, you know, in giving students and teachers feedback on what students know and don't know, in trying to avoid assessing things that are not CS content knowledge. Like, you know, as Lily's just said, the Freyer model is really asking students to justify their answers and also helping them, you know, teaching them like how to answer those kinds of questions. In terms of the videos narrating the code and explaining the code trace instead of just answering a multiple choice question that does that, like it hopefully gives students and teachers feedback on, you know, what they know and what they don't know. I do like using the Freyer model. I do use it quite a lot. yeah, Ariana's slides on the Parsons problems is a good template, and Ariana was very proud of the lines and the fact that you can do the alignment in it. But she's not here to kind of say how much she enjoyed making that work. Are there any more questions? Any suggestions for other ways of assessment?
Okay, so this is totally off subject, but in the chat, I put that my daughter goes to Cardiff University, is getting a PhD there. And she was so excited that you were going to be here. Because I said, hey, I just read about the person who's coming. So anyway, she just started this year.
Great. Yep. I spent a lot of time in Cardiff in the Glamorgan building, which your daughter will know.
So Ruth, if there's no more questions or comments, and we want to make sure everyone has an opportunity, if you'd like to even verbally share your takeaway, we're open to you unmuting and connecting with us. We're going to give it 1 more minute and then we're going to wrap it up. Is that okay, Ruth? And I also want to say too that the first part of your presentation and how you actually showed actual assessment questions and critiqued what are we really assessing here. I think that's just a very healthy way to approach whatever assessments you've used in the past, to go back and look at what are you really assessing and getting a pair of eyes that are not yours, because we're so used to, sometimes we're just so comfortable with our assessments. So I think that's a wonderful approach to really taking a look and evaluating your assessments. There's a question, I was wondering if you had a chance to use single point rubrics and how do they compare to traditional rubrics?
I have used single point rubrics before. I tried them out with a class. I think that I quite like them, but I think that it needs more than one teacher in a school to be using them. I think the kids were confused. So I think if you can get other people on board with trying them out, if you've got a grade level where you're trying them out, then they could be an interesting way to approach it. But I think I was probably the only person who knew what was going on. So in the frame model, if the answer is right but the justification is wrong, then the answer is not really right. The answer is right by accident, and so it needs, depending on whether it's all the students or it's one student, it needs some remediation to deal with that misconception, whatever it is.
I was thinking about from a grade standpoint, would they get the same grade as somebody who just totally marked the wrong answer, or would they get a different grade?
I think it probably depends on how wrong their explanation is, but I don't they wouldn't be getting the same as somebody who gets it right for the right reason. Depending on how wrong their reasoning is, then would depend on where they'd land. they'd probably end up, in our scale, they'd probably end up in developing. Just right answer, wrong reason.
There's a comment in the chat that reads, "Thank you for opening my eyes to rethink my forms of assessments, even though they are not as complex since I teach kindergarten, but just a deeper look into what I'm actually testing or looking for my students to learn and remediate based on their results." It's a really awesome comment in the chat. Are you okay, Ruth, if I wrap it up from here? All right, thank you, Jason. I'm going to share screen. We wanted to thank everyone for joining us today. We'd love to get some feedback on today's webinar. And also, if you would like to receive a certificate of completion for your time here, please complete the survey. It will automatically send you that email upon submission. We also want to draw your attention to what we have coming up. Our last professional learning series for the winter ends this month on March 31st. It's a code and play. Code and play is when we have different platforms that you can learn about or try out or collaborate with others. We have someone who'll do quick demos, and then you have a lot of play time to do that with your colleagues. We have the Equity in Action Summit that's on April the 2nd. The theme is committing to inclusion. It is a virtual event, and we'd love to see you there. We just recently inputted the next series for the professional learning series spring. We are starting off with our teacher takeaways from the SIGC 2022 Tech Symposium. And then we have some awesome panels and Heritage Month resources, one for Asian Pacific Heritage Month in May. So that's gonna happen in April. And then to prepare for Pride Month, we're gonna do, it's called the Outstanding Voices, a panel and a resource sharing for that for June. So we just want, we're hoping that you can join us. Here is our upcoming events for spring. And we are so excited for you, hopefully, to join us at the Equity in Action Summit. But thank you so much, Ruth, for presenting this material. It was amazing. There's so much for us as teachers to really reflect on why we are assessing the way we are, and then really figure out, is there a better way so that it could be more equitable for our students, or really tackling, are they learning what we're trying to teach them? So thank you all. We hope you have an amazing evening, morning, afternoon, wherever you're tuning in from. Hope to see you at the next event. Thank you.